We've introduced the idea of definite integrals. We've talked about methods for coming up with approximate areas. We've looked at how to find exact areas, assuming that we were already given the areas under the curve and we're just adding and subtracting those from each other. But the real question is, how do we actually just, given a function, an upper and lower bound, how do we integrate that and calculate that area under the curve? So to do that, to find these exact areas, we're going to use a very powerful theorem in calculus that unites derivatives and integrals. And this particular theorem is called the fundamental theorem of calculus. Again, because it is so powerful, ties together these two prime concepts from calculus into one theorem to show us how we can evaluate these different results. So if f is continuous on some interval from a to b, then we can evaluate the definite integral from a to b of f of x dx as capital F of b minus capital F of a. So really essentially what we're saying here is, given some function, we find its antiderivative or its indefinite integral, capital F of x, and then we evaluate that function at the upper bound and lower bound and find the difference. So in practice, to calculate definite integrals, we first find the antiderivative of our function lowercase f. We evaluate that antiderivative at both a and b, so the lower bound and the upper bound for our definite integral, and then we take the difference of those two results, which again is expressed by f of b minus f of a. So we start off with the idea of indefinite integrals to get this antiderivative, and then we just evaluate that antiderivative at the upper bound and then subtract evaluating it at that lower bound.